common term that we normally use in our society today. Now, when you come to your houses or when you come to your society, you will hear the word like copper, you hear the word like iron, aluminium. Even when you get to your houses, some cooking utensils that we use at our various homes are made up of what you call metal, such as our spoon, our pot, and so on. So, in today's chemistry class, we are going to be talking about what we call metals and their compounds. Welcome to Brain Doctors Academy. I still remain your anchor, Mr. Ken. If you are new to this channel, kindly subscribe and click on the notification bell icon. Also share this link as well. Without wasting much of your time, let's get started. Okay, let's start with what metal is all about in chemistry. Sorry. So let's start with what you call metal in chemistry. Now, metal, the word metal, basically they are what metals are elements that ionize by electron loss. So I can just say that metals are elements that ionize by electron, or by losing electrons. Let's put it this way: by losing what electrons. So by losing electrons. So it basically means that for metals, metal normally lose what? Lose electrons. So now these metals has one basic features they have in general. They are elements that bond in oxygen. So which means they normally undergo what you call combustion. So they are elements. They are elements that bonds in oxygen. And whenever they bond in oxygen, what are we going to get at the end of the day? If they bond in oxygen, they will yield what you call basic oxide. To yield basic oxide, which if soluble in water, forms an alkaline. So in general, it simply means that most times this metal we're talking about bonds in oxygen, and anytime they bond in oxygen, you will get what you call basic oxide, and soluble basic oxide give what you call an alkaline. Okay, now let's go over to properties of metals. Let's talk about the physical properties of metals. Physical physical properties of metals. What are the physical properties of metal? Now, the physical properties of metals that we have are: number one, they are all solid. All metals are solid. They are all solid. They are all solid except mercury, which is liquid. Except mercury, except mercury, which is liquid, So mercury is the only metal that we call liquid metal. Now, I will need you to do a favor for me. As I'm writing out these points, please bring out your writing materials and take them down as well. And for you to enjoy this video and for you to understand or follow up with everything that I am doing, I would strongly advise you rotate your phone, put it in a landscape mode, so that you will see exactly what I'm writing instead of leaving it in your portrait mode. You may not be able to see clearly all I've been writing. All right, let's proceed. Then another thing we have is that we've talked about the first feature of that physical property of metal. Now the next property of metal is what? They have high densities. They have They have high densities, melting points, and boiling points. And the reason why they always have high density, melting point, and boiling point is because of what now? This is because of what? Due to strong metallic bonds of the metals. So the reason why metals always have what you call high density, high melting point, and high boiling point is due to what? Um, is due to strong metallic bond, due to strong strong metallic. So you should bear it in mind. The reason why it has high density metallic bond, strong metallic bond, so of metals, strong metallic bonds of metals. No, sorry, of metals. So this thing simply means that if you weigh it by that now, for all metals now, the mass per volume of every metal, metal do have more mass per volume. That's what we mean by the density. So which means that if you weigh it, it looks like it's going to have more weight, but it has more mass at a particular volume. That is all metals. And their melting point is always high. Their melting point is very, very high, and also their boiling point is also high. So we have high densities, melting and boiling points. And the reason because we have a high density of melting and boiling points is because of what you call due to the strong metallic bonds of metals. So metals have what you call strong metallic bond, and because of that metallic bond, it makes the metal to have what you call high density melting and boiling points. All right, so the next feature is what you call they are ductile and malleable. They are ductile, meaning that we can draw them into wire. Ductile and what? Malleable. Malleable in the sense that it can be beaten into sheets. Ductile and malleable due to what? Due to uh, the due to their atoms are closely packed. Their atoms are closely packed. Are closely packed. Are closely packed, and their atoms are closely packed regularly in layers. In layers. In layers of the same size, which slides over which slides over each other as each other as force is applied. So that's the next point that we have there. All right, the next feature that we're going to talk about is the next physical property that metal have is what you call they are good conductor of heat and electricity. They are good conductor of heat and what? Electricity. Heat and what? Electricity. And what's the reason why they are good conductors of heat and electricity? Sorry. So the reason why they are good conductor of heat and electricity is because the presence of what? Delocalized or mobile electrons. So we just say due to the presence of delocalized delocalized sorry, this is supposed to be s delocalized or mobile electrons. So that's the reason why it's so. Then another feature that metal has is what you call metallic lustre. And when you say metallic luster, it just simply means that the metals are always shiny in nature. So like they are shiny, so they have shiny property or ability. So number five, they have metallic luster. They have metallic what's luster. So which means that they are shiny. So these are the physical properties of metals that we have. So let's go over to what we call the chemical properties of metals. Now, coming to chemical properties of metals, I would like you to just understand only five headings. That is the chemical properties of metals generally. Every anytime you see it, always come up in five. First of all, you are going to know how does metal react with oxygen. How does metal, any metal that you see, how does it react with oxygen? That's what we are going to talk about. You're supposed to understand and know everything about the combustion reaction. Every metal, how does it react with oxygen? Does it react with oxygen, or does it mean it doesn't react with oxygen? There are some metal that react with oxygen, and there are some metal that doesn't react or burn in oxygen. Let me use the proper word. The proper word is burning in oxygen. That's number one. Then uh, number two that we're going to talk about is reaction with water. Some metal react with water and some doesn't react with water. You really need to understand those metal that react with water, and anytime they react with water, what is going to be the end product, and what is going to be the product of any time they react, or anytime the metal react with water. So you are supposed to understand every metal, their reaction with water. So that's number two. Then number three that you need to know is what you call reaction with acid. Actually, it's not acid. I mean reaction with dilute acid. So it's going to be reaction with dilute acid. How does metal react with dilute acid? What is the end product anytime they react with dilute acid? Do they react with dilute acid, or they don't react with dilute acid? These are the things that you need to know. And anytime you have idea of all these things, it simply means that you can answer any question that comes in metal. That's number three. Then number four is what you call reaction with conc acids. We have reaction, reaction with or action with reaction with conc acid. So this metal, which of them reacts with conc acid? Which of them that doesn't react with conc acid? You need to know all these things. And if you're able to know all these things, like, as I said before, you'll be able to survive or answer any form of question that comes up in this now. So basically, the thing we're going to consider under this chemical property is going to be what? Four. Now, it is true that um, when we go over to see some metals individually, some of them can even go beyond these four that are listed. There's possibility that some of them can react with ethanol or react with other elements or other compounds. But basically, all metals that we're going to be talking about must fall under this four category that I listed here. That's it now. So let's take the one after the other. Let's start with what you call combustion reaction. Let's check if metal burn in oxygen or they don't burn in oxygen, and which metal burn and which of them that doesn't burn in oxygen. So that's what we are going to start with. So for the first one, I have the first one as combustion reaction. My first one is combustion what reaction. Okay, combustion reaction now. Now, I actually forgot to list to your class the metals that we have. Most students, the only metal they know is iron, aluminum. These are the metal they know. Whereas some of them forgot that we have series of metals like potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, and lead, copper, mercury, silver, and gold. So actually what I have here is just an activity series of metal. How these metals react. This is activity series of metal. So if I'm going across this way from left to right, their reactivity, or yes, their reactivity decreases. So which means that the most reactive metal that I have here is potassium, followed by sodium, followed by calcium, followed by magnesium, followed by aluminium. So this activity series of metals is they arranged metals based on their reactivity, how they react. I hope you understand what I'm saying. Like, I hope you are actually following me. So the way they arrange this thing, they arranged it in the way they react either with water or with acid, or how they react with oxygen. So that is it. So since I've already talked about this in a combustion reaction, we cannot have combustion without oxygen. So let's see this now. Oxygen must be present. So under combustion reaction, we have it at potassium, sodium, and what? Calcium. These three elements that I listed out here now, they do what now? They burn readily in air. They burn readily in air. Potassium, sodium, calcium burn readily, readily in air. And this our air that we're talking about comprises the following. Air has oxygen, air has carbon dioxide, air also have water vapor, and so on. So, but the major thing that we need to pick from this air is what you call oxygen, because our air always have oxygen. So potassium, sodium, calcium bonds in air, bond readily in air to form oxides. Not oxide, like oxide, to form to form to form what you call oxide. They form oxide. So which means that if I have checked about it now, we have something like potassium plus oxygen to give you what you call potassium oxide. So that is exactly what we have here now. That is for this reaction. Then you can also say that, then whereas now, since I just said that potassium, sodium, calcium born in air or oxygen to give you to form what you call oxide. This is the oxide that it formed. Then magnesium, aluminium, zinc, iron, tin, lead, copper, and mercury. These three. So I have it as magnesium, aluminium, zinc, iron, tin, lead, copper. Okay, these metals that I listed out now, they form oxide when heated in air. So they form oxide. They only form oxide when heated. If you do not heat them, they can't form oxide. When heated in air. I hope you're taking down this thing that I'm writing. Just take them, because the more you write, the more you understand. Okay, um while silver and gold has no reaction with oxygen, has no reaction has no sorry has no reaction with what? With oxygen. With oxygen, it has no reaction with what? With oxygen. Okay, so that's it. So we have just talked about the combustion reaction, and we've just seen that potassium, sodium, calcium bond readily. You don't actually need to heat them or do anything for them to react with oxygen to form oxide. But there are some other elements such as magnesium, aluminium, zinc, iron, tin, lead, copper, and mercury that actually need you to heat them first before they can be able to combine or form oxide with oxygen. So that is it. Okay, so another feature that we're going to talk about apart from combustion reaction is what you call reaction with water. I listed this in out. Reaction with what? With water. That's the next one. The second one is reaction with water. Now, coming to this now, I have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead. Now, aside this now, between this lead and iron or a copper, we're supposed to have hydrogen here. We're supposed to have hydrogen here. So it just simply means that all these metals that I have here, whenever they react with, let's say, acid or acid or water, that is metals that are higher in the series, metals that are before hydrogen, we always displace hydrogen from, let's say, acid, even water. They can also displace hydrogen from a compound that has it. So let's see this now. We have this now. We have the potassium, sodium, calcium displaces hydrogen, which means, but this reaction is very vigorous, like it's very explosive. So displaces or displace hydrogen from cold water, okay. So potassium, sodium, calcium displaces hydrogen from cold water, so which means that, so the next one is this. Let's continue with the next one, which is magnesium. Magnesium, aluminium, zinc, iron, tin. Then what did they do? They displaces hydrogen from steam. So this steam we are talking about is gaseous water. That's your gaseous water. Okay, so from steam, okay, at red hot. So you must heat them at red hot before such events occur. While elements such as what? Such as lead, um, copper, mercury, silver, and what? Gold do not react with cold water. Do not react with what? Cold water. They do not react with cold water at all. So you see, 1, 2, 3 displaces hydrogen from water, and they do that readily. Then magnesium, aluminum, zinc, iron, and tin does that at what condition? The water is not going to be a cold water, rather it's going to be what? Steam. Then lead, copper, mercury, silver, and gold doesn't. Even if you like use steam, even if you like use cold water, no reaction, nothing happens. They will never displace hydrogen from that water. So this last one doesn't do that. So okay, so that's it. The next property that we're going to talk about is reaction with dilute acids. So let's talk about the reaction with dilute acid. Now, coming to reaction with dilute acid, we have a reaction with dilute acid. The dilute acid. Okay, so what happened now? Then potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead react with dilute. With they react with dilute acid. They react with dilute acid to form what? They always give you two products. The two products they will give you is what? To form hydrogen and what? Salt. So these are the two byproducts we are going to get. Then you should also take note of one thing now. Aluminium reacts only with dilute HCl. And when you talk, then as well, lead reacts with what? Dilute HNO3 to form what? To form oxides. oxides of what? Oxides of nitrogen. Sorry, let me put it here. Oxides of nitrogen. Oxides of nitrogen. Then the remaining elements such as copper, mercury, silver, and gold has no reaction with what? Has no reaction with dilute. With what? Your dilute is dilute what? Acid. Okay, so that's it. Dilute acids. Then the next point is what you call the action with conc acid or reaction with conc acid. So let me put it this way: say action with what? Conc acids. Okay, all these things that I'm explaining now, when we go deeper, we are going to be seeing them one after the other, because in this this class we'll be picking some of the metals and be talking. We are going to go into in-depth discussion, explaining some metals and their compounds as well. Not all metals, so we're going to explain some metals and their compounds as well. All right, so let's say action with conc acid now. Now let's start with the first conc acid that we have here now. Let's say conc HCl. What happened? Which of the metals react with conc HCl? Let's find out the metal that reacts with conc HCl to give you. Remember, let's find out metals that react with conc HCl, and let us talk about and find out their end product or the product it's going to give us. Okay, so metals such as potassium, sodium, calcium, magnesium, aluminum, zinc. Okay, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, and the last one, which is tin, reacts with conc HCl, react with conc HCl to form two things. To form what you call, normally now it will give you hydrogen. Hydrogen must be involved. Hydrogen and a salt. And a salt. So these the two things that we have, while the rest has no reaction. While the rest has no reaction. So the rest of the metal has nothing to do. They have no reaction. So that's it. So the next one we are going to talk about is be part of it. Let's say conc H2SO4. Which of the metals react with conc H2SO4? All right, we have potassium, sodium, calcium, magnesium, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper, mercury, and what? Silver react with this to give to form what you call sulfur oxide. So while our gold has no reaction, has no what? No reaction. Our gold has what? It has no reaction to this. All right. So um, the last part of which is option C, we have a conc HNO3, conc HNO3, magnesium and aluminium. Magnesium, we have magnesium, aluminium reacts to form that they react with HNO3 to form uh, to form dinitrogen one oxide and N2. They also we also have that and your tin, your lead, copper, mercury, silver as well react react to form uh, to form um, nitrogen. Okay, to form our NO, and then we or NO2 depending on the acid. Okay, so depending on the acid concentration, While we talk about the gold has no reaction. Gold doesn't react at all. So gold has no reaction to this concave here. So we can say that our gold has no reaction. All right, since we've talked about what we call the chemical properties of metals, the general chemical properties of metals, let's go over to metal in question. What kind of bond do they have? Metal is built or experience or have what you call metallic bonding. So bond in metal, the kind of bond that we have in metal is what we call what? Bond in metal. The kind of bond we have in metal is what we call metallic what? Bonding. So we have metal has what we call metallic what? Bonding. That's exactly what metal has. So now, and when you talk about it means that the metal atoms are being held together by a force known as what? Metallic what? Bonding. Now, before we go over to other things now, let's talk about what you call the flame tests of metals. Let's run a flame test of various metals, and let's see their colors of these metals or these metals in flame. So that's exactly what we're going to do right now. So let's see this their flame test now. So I'm going to say flame tests, flame, sorry, this is flame. I'm going to say flame tests colors of common what? Metals. Common metals that we have. So let's see this now. So I'm going to first of all list out the metal here, or even its elements. The metal I'm going to list here is either the element or the ion, anyone. Then I'm going to say their flame color. Now, flame color. Now, this color that I'm referring to, even if you find the metal in a compound, and you place that compound in fire, because of the presence of that metal, the metal must show its color. So it's not a must that it's going to be the metal itself. It can be a compound, like it, because normally the compound, you are going to get the ion from that compound as well. So let's see this one, something like sodium. The color of sodium is what? Bright yellow. Flame test. So for sodium is what? Bright yellow. It gives you bright yellow. Then we have another one like potassium. Potassium has what we call what now? Lilac. So lilac. Be careful. Remember what I said. It's never a must. Now let me explain further how I mean that. For instance, now, assuming I have something like potassium chloride, and I was told that I picked up this sample and placed on fire, and probably I'm seeing a lilac coloration or lilac flame. It just simply means that there's presence of what you call potassium. So it's not a must, it's going to be potassium metal. The potassium ion is from this compound in question. So it's from the compound in question. That's what you call that now. All right, so we have the next one known as what? Calcium. Calcium gives what you call brick red. Gives what you call the brick red. Then apart from calcium, what else do we have? What other ones do we have? So the next one I'm going to talk about is what you call barium. Okay, so let's say barium. Okay, this one, the color is what? Pale green. Pale green, or you can say yellow green. Yellow green. That is for the barium. Then we also have lithium ion. Lithium ion. The color of this one is going to be what? Crimson red. Crimson what? Red. Then I also have copper 2 ion. Copper 2 ion. And the color of copper 2 ion is what? Blue green. I have it as what? Blue green. So the flame that gives you blue green is what? Copper 2 or turquoise. Okay. Okay. So the next one is what you call ion 3 ion 3 ion, and the ion 3 ion will give you what you call the gold sparks. It will give you the gold sparks. So the color is going to give you is the gold sparks. Then the next one is what you call lead ion. We have lead ion, And lead ion will do what? Will not give you any flame, will not give any color to the flame. So this one is no distinct what flame color. So that's what we have here. So that is for the lead. Then we still have others such as magnesium. Let's see, we have magnesium ion, and this one will give you the bright white. It will give you bright white. The color is going to be bright white. Then we also have aluminium. Aluminium will give you no color. It will give you any color on flame test. So we also have tin. Tin 2. Tin 2 has what? No characteristics what? No characteristic color. Then manganese is going to be what? Yellow green, but this kind of yellow green is the weak one. Yellow green, it's not going to be intense, it's going to be weak, the weak yellow green. So that's it. Now before we talk about, or before we start talking about the various metals, like the alkali metals, the alkaline earth metals, the transition metals, and so on, let's talk about how do we extract these metals, extraction of metals. So let's talk about what you call extraction of metals. How do we actually extract them? So we have extraction of what? Of metals. How do we extract these metals now? Now, we always extract metals by what you call reduction method. And the reduction method that we normally use are into two. So we have one, reduction by electrolysis. That's the first one. Reduction by electrolysis. Okay. Then the second one is what? Reduction by what? By coke. And this coke is carbon. It's actually carbon. So reduction by what? By coke. Now for the first one, known as reduction by electrolysis, this electrolysis is very, very costly, because you are going to make use of electricity to carry out this one. So but this one is basically used for elements that are very, very reactive, and they are not free in nature. So they are very, very reactive now. So this reduction, this one, so reduction by electrolysis is used to extract the following metals, such as potassium, sodium, calcium, magnesium, and what? Aluminium. So these are the metals that we extract using what? Electrolysis or electrolytic reduction. So the next one is thermal reduction, or reduction by coke. So reduction by coke, we use others. Reduction by coke or carbon. That's our carbon now. So reduction by coke now, we have metals such as, the metals are, we have metals such as zinc. Okay, let's say we have metals such as zinc, iron, tin. We have tin and what? Lead as well. So these are the metals that we extract by what? Reduction by what? Coke. So I'm going to explain further. In my next class each of these metals, but you should bear it in mind that 1, 2, 3, 4, 1, 2, 3, 4, 5 is by electrolysis. 1, 2, 3, 4 is by what? By the use of carbon, known as coke. So just bear it in mind, so that when I come next, or when I start explaining next, you understand fully. All right. So we are going to just have a little break here. I'll continue. I will see you in my next one. Now remember that if you are new to this channel, please kindly do what? Subscribe. You can also share this link to your friends so that they will also learn